So nuclear power part two. What are the pros and cons? Because they'll put this on the test, right? Um, there are a lot of pros, right? Right now, the thing that's in the news is this, right? There's less greenhouse gases emitted, right? New designs are safer. So the old designs that we have, we've had a few accidents with those. We'll talk about at least one of them, right? With a crazy design that the Soviets had, right? But one of the pros is that we believe we have enough uranium on this planet, and that's just uranium. There are other fuels you can use if you're a little bit crazy, but there's enough uranium to just do uranium fission reactors for thousands of years. Okay, and probably in 1,000 years we won't need nuclear power, right? Um, One of the pros that they're talking about, I mean, we can talk about, and I will talk about some of the casualties we've had with nuclear power. But coal plants, it's estimated due to air pollution, this is what we're burning now, right? Coal is causing on the order of 7 million deaths. And this is lung cancer and all sorts of stuff due to air pollution per year, right? I mean, two wrongs don't make a right, but nuclear power we're not close to that. It's a few hundred maybe, right? Okay, so or thousands if you look at the whole Chernobyl thing, right? It's definitely not 7 million deaths per year, right? Okay. Cons with nuclear power. What do you do with the waste? I think we were going to, was it Yucca Flats or someplace in Nevada? We were going to make a waste depository, and was it? I think George W. Bush had them all in line to do that. I think Obama needed the votes in Nevada, right? And so he said, "Oh, I'll oppose this thing." So now we don't have a place to do it. It was all politics, right? Obviously, there's a danger of meltdown or worse, right? Nuclear power plants are pretty expensive. They're billions of dollars to start up, but they're overall for the life of the reactor, 30 years or so, the overall expense is cheaper, right? And they don't emit greenhouse gases. So basically, our mix in the future, we think our mix is going to shift to nuclear energy, and we're going to run out of nuclear engineers. So if you like nuclear physics and you get a major in nuclear engineering, let me just say that you will get a job. And we don't know where the other people are going to come from that are going to fill those positions. Okay. And then, obviously you've heard of Chernobyl. We've had 3 Mile Island. Recently we had Fukushima, was kind of a disaster, right? But Chernobyl was kind of like that. That was exceptional, right? We use water to moderate our reactors. Water doesn't burn. The Soviets used graphite. Now, the advantage of graphite is you can operate a graphite reactor at a higher temperature. The higher the temperature is, right? What is our Carnot efficiency? Is 1 minus T low over T high, right? Okay. The higher this high temperature is, the more efficient the plant is, right? So what happened in Chernobyl was that they overheated the core and they lit the graphite on fire. It wasn't a nuclear fire. It was a graphite, a chemical fire lit by a nuclear reaction. The Soviets basically sent firefighters in there. They didn't tell the firefighters at this rate, they were sending them to their deaths. Okay, like in 9/11, the firefighters that raced up those stairs to save people, they knew they were going to die, right? These firefighters didn't know. They were just sent unwittingly to their deaths by the Soviet empire, the evil empire, as Ronald Reagan said, right? Eastern Europe found out about the Chernobyl disaster because workers walking into nuclear facilities were setting off radiation detectors, right? They were getting radioactive not on their job site, but at home, right? This horrible stuff in a firestorm was raining down over the fields. And the crazy thing is that strontium is in the same place, the same period or something as calcium. Radioactive strontium was getting into the milk because of course milk bonds calcium, so it of course will bond strontium. Chemically it's the same, right? And people were drinking milk with radioactive strontium in it, and they didn't even know because the Soviets didn't tell them. We can just do a little, well, you can take a look here. This is the reactor itself after the explosion. It looks a little different today. This is an abandoned city. Like people just, it's like Pripyat or something like that is the name of the city. People just abandoned the city. And obviously people are going in. This wasn't there when the thing happened, right? people are going in there, and this is somebody standing outside the reactor. They've now built a thing over the reactor core. That's a Geiger counter. People go in there. If you know what you're doing, you're probably okay. You don't want to go in places where the radioactive fallout fell and concentrated. You have to be careful. Like, you have to be careful going into buildings. You don't want any of that stuff going on. If these windows are open, those buildings could just be death traps for you. But anyway, and then check this out. The core, eventually, all that uranium that was in there, right, melted down. They call this the elephant foot. This guy's definitely gone. This guy is with Jesus now. I mean, just think of all the holes in his body. This thing is glowing red hot from a nuclear fusion or fission reaction, right? But anyway, yeah, there we go. This is a picture of the dead zone. These are places where you just don't want to go. Now, there still are roads in this area, so people go in there and drive on the roads because cars wear out roads, and there are no cars allowed in these exclusion zones. So there aren't any police there either. So, and the final thing I'm going to leave you with is that this is, this is the Fukushima style reactor. There are, and you just do a search about it. I'm not knowledgeable about this, but this is like a molten sodium thing. There are people that have designed reactors that are much better, much safer, much easier to maintain. This thing can go for decades without really having to do a whole lot of maintenance on it. There are some of these things that are like essentially like nuclear batteries. You can just start them up and they just go. They just automatically monitor themselves. So yeah, back in the day, I definitely was a anti-nuclear demonstrator. Now I'm a reluctant realist and realize that probably climate change is going to kill a whole lot more people than 100 Chernobyls, 1,000 Chernobyl. I mean, pick your number, right? Okay. So I think if it's done well, one of the other dangers that we didn't talk about, right? The cons is proliferation, right? Proliferation. That is, countries that have nuclear reactors, it really is just not that big a step. If you can refine the fuel for it, you can make bombs, right? You have to also be very careful with the waste, okay? Because the waste has plutonium, and plutonium is chemically different. And if you refine it, you can make a bomb. Anyway, I think that's, I could go on and on about nuclear power. I'm going to stop though.